What? DeFi? No, never heard of it. Hi everyone, I'm Alex and welcome to the second episode of Beam Pulse. Today we're going to talk about DeFi. What else? Specifically Beam progress in this area, and we'll also discuss how Uniswap works under the hood, and I will also tell you about one of my favorite movies that I really like and how it is related to Beam development process. So let's get started. The title of this episode is sponsored by, me, Alex, CTO of Beam. You're welcome. Even if you're not superstitious, there are certain omens that you definitely need to look for, like double rainbow, for example.
It is a double rainbow. I cannot believe it. It's a freaking double rainbow.
But in Beam, we have good omens of our own, and today I will show you how to find two of them. So the first omen is the appearance of the release candidate branch. Since before each version is released, we create an RC branch and then we test it and deploy it to testnet first and then to mainnet. So if you go to the branches list and you look for RC and you see the 5.1 RC branch there, then you know that the release will usually follow very, very soon. Another omen is when one of Beam developers or some branch suddenly shows a lot of commits all of a sudden. And this is how you know something interesting is going on. So it's a little bit difficult to spot because by default, GitHub only shows the activity on the main branch, the master branch in our case. But if you go to the inside section and on the left choose the network tab, you will see that some branches are way ahead of the master. So this is how you know that something interesting is going on there. As you know, we're currently working on the DeFi platform, and one of the branches that you'll see there is called Beam DeFi. And you might think that it's somehow related, and of course, you would be right. So let's see what is going on in this branch. I will save you the need to drill into the code and give you a quick overview of what's going on there. So first of all, there is a new Beam virtual machine that is running inside the node, and Beam script assembly language, which is a low-level programming language that is used to program the said machine. What this allows us to do is to write Beam contracts and to add new types of transactions as calls to these contracts. A contract can control emission and burning of confidential assets, lock and release UTXOs, implement the contract business logic, and also call other contracts. Now, each contract is uniquely described by its code, as well as the initialization parameters, making it impossible to create two exactly identical contracts on the chain. And in addition to making it possible to build all kinds of DeFi applications, the contracts will also be used for bridges and with existing chains such as Ethereum, and also for Beam sidechains that will be created in the future. Now, if you look deep enough, you will find the work-in-progress version of the confidential algorithmic stablecoin contract that we will showcase in the coming weeks. There is a lot more to come in this area, so stay tuned, subscribe to our channel and our newsletter, and you will save yourself a lot of time by being automatically updated on all the news instead of asking when big news in our community channels. So, in our next segment, we will talk about Uniswap protocol and how it works under the hood. But first, a minute of culture. Today, I would like to tell you about one of my favorite movies, Wag the Dog from 1997. So the story takes place in the United States 2 weeks before the elections, and the president is accused of sexual misconduct with a young girl that was visiting the White House. In response, the president summons a mysterious political spin doctor, played by Robert De Niro, who in turn asks a Hollywood producer, played by Dustin Hoffman, to help him to create a fake war to divert the public attention from the scandal and eventually help the president get re-elected. Now, if at this point you say, wait a minute, this sounds very familiar and reminds me of the Clinton-Lewinsky scandal, you would be right, except, and this is really crazy, this movie was actually released 1 month before the Clinton-Lewinsky scandal broke out. This is not, however, why I like this movie. Alongside the political intrigue, the movie makes a very nuanced and subtle illustration of the production process.
You know, you're a writer. That's your script. You're a director. But if you're the producer, what did you do? See, nobody knows what you do. The producer, I mean, all he's got is the credit. You see, some plaques on the wall. They don't know what we do. Stan, don't get me started.
The improvisation, how team plays off each other.
What is it?
What time is it?
What is it?
3:03.
Great idea.
Dustin Hoffman, in one of the interviews, called it this nutty optimism. And this is something which is very relevant to software development in general and to Beam in particular, because we often find ourselves in these situations where we need to improvise and quickly change direction, support each other and complement each other in various ways. So I always found this movie to be very motivational for me in this regard. Now, adding to this fact that the movie was directed by Barry Levinson, who also directed Rain Man and Sleepers, and the cinematography was by Robert Richardson, who before that shot Platoon and Natural Born Killers, and after that most of the latest Tarantino movies, including Inglourious Basterds and Django Unchained and The Hateful Eight, and also a very long list of unbelievably famous movies. And if the music of the movie sounds familiar, well, it's from Mark Knopfler from Dire Straits. So overall, highly recommended.
Good. Heartfelt.
Touching.
Touching. Oh, people will weep.
In this segment, we're going to talk about the Uniswap protocol. And let me tell right off the bat that this is not a trading advice of any kind or a recommendation to use or not to use this service. We're strictly interested in the technology. And there are several reasons why I find this protocol very interesting to explore. So the first reason is that instead of using external oracles to determine the price of a pair of assets, it uses basically human greed in a way, specifically by creating arbitrage opportunities. And the way it works is by using something called automated market makers, which is actually the second reason why this is interesting to explore. Now, automated market makers are used instead of the order book mechanism to create an exchange. In the order book model, the liquidity and the price are determined by the user setting orders, which are in turn matched, and it requires fast propagation and fast matching, which usually breaks a lot of strain to the network throughput. And instead, in automatic market makers, the trade is conducted directly versus the contract. There is no order book, and this is why it works better with blockchain architecture. There are quite a lot of different types of automatic market makers, and this is, of course, far beyond what we can cover in this short video. But basically, they're classified by the mathematical function they use to determine the relative price of the asset pair. And the one used in Uniswap is called Constant Product Market Maker, CPMM, and it is described by a simple-looking formula, basically multiplication of the quantities of the two assets in a pair, and it should be equal to some constant called K. All the articles that I have used as resources for these examples that I'm going to show, in addition, of course, to the Uniswap documentation, will be listed in the description to this video. But let's start here with the graphical representation of the constant product function. And to understand what it means, let's take a simple example. Let's say we trade bananas for apples, and initially we have 50 of each fruit in the pool. If we take one apple, there will be 49 apples in the pool. But since the product has to remain the same, we obviously need to pay for it with some amount of bananas. Now, a simple calculation will show us that we need to contribute 1.02 bananas to get one apple. Now, if you remember, originally the price for one apple is one banana, but we had to pay 1.02. So this difference is called slippage, and it really gets larger the more apples we want to get. For example, if we want to get 25 apples, we would need to pay 50 bananas, basically 2 bananas for each apple, i.e. twice the original price. However, in addition to the traders that use Uniswap as a decentralized exchange, there are also liquidity providers who supply the coins to the pools and in exchange get 0.3% for each trade. The fee is distributed pro rata to all liquidity providers at the moment of the trade. Technically, the way it works is that each time you provide liquidity to the pool, you receive a pool token, which can be later exchanged for the original funds plus the accumulated profits. Now, this, in fact, is exactly the idea that made Uniswap so popular. Instead of having your coins just lying there in your wallet, you can make 0.3% from each trade simply by providing liquidity to the pool. There are, however, some subtle risks that are specific to this type of market maker beyond the obvious bugs, scams, and other potential problems that are common to all contracts. So let's go back to the banana example to explain. These bananas are real useful. So let's say due to a sudden shortage, the price of bananas skyrocket, and while it was previously worth 1 apple, now suddenly you can exchange like 1 banana for 5 apples for a single banana. So naturally, the arbitrageurs run to the pool to take advantage of this situation. They buy bananas, so they will still make profit when they resell them, and you can see the calculations on the slide. But if you come to think of it, where does this profit come from? Well, it comes from the pool liquidity providers, obviously. In fact, pool LPs would actually lose money versus holding the same asset in case of sharp price changes in either direction. This phenomenon is smartly called impermanent loss, implying that the loss would be offset if the prices move back to their original position. And as you can see in this chart on the screen, there is a small zone where the LPs are profitable, but if the price deviates larger than this zone, then they can actually lose money if they pull it out. The most money they make is if the price when they pull out is actually the same as the one where they put their money into the pool. It is important to know that other AMMs with different formulas have different behavior for both risk and slippage, so it's important to understand which type of AMM is used in a specific project to understand which risks apply to you. So this is all we had today to say about Uniswap, and we will continue to investigate DeFi protocols in further episodes of Beam Pulse. In the meantime, thank you very much for watching. Please subscribe to our channel and have a great day.